Hello everyone. Today we will be reading linear equation, the first chapter of linear algebra book by David Sile, and we'll be discussing. It is my note, and I want to share my knowledge in these videos. So first, today we will be discussing what is linear equation and what is system of linear equation, what are solution sets, and we'll be discussing some examples how to solve the system of linear equations and many more. Let's deep dive in. So first, 1.1 system of linear equation. What is linear equation? A linear equation in the variable x1 x2 up to xn is an equation that can be written in the form of uh, a1 x1 plus a2 x2 up to an xn is equals to b, where a1 a2 up to an must be real or complex number. Why complex number? Why we are adding complex number is it will be a little bit easy. We will be dealing a lot with complex numbers. The world is not only satisfied with real numbers, so there will be complex numbers to deep details. We will be further. This will be discussed in further videos. So when we observe the patterns, look at here. Here on the variables, and there is degree one, and this b is also real or complex number. When we discuss the linear equation, it is not much about like it is set out in the rule that it must be. When we write equation, why when can we say this is a linear equation is if we have a degree 1 and the coefficients are real or complex number, and there is b which is also real or complex number. So the first set, like this set, let's look at this set. Are they linear equations? The answer we'll be discussing, like for x1 there is x1, and when it comes here then it goes 3x1 minus 5x2, this plus 2. When it goes here and goes minus 2, does it look like this equation? The answer is a yes. Yes, a1 pretty much looks like a3 and x1. A2 looks like minus 5 and x2, and up to there is, we can reject them. And there is b which is called minus 2, and now it correlates with this first equation, so uh, it is linear equation. Now second, x2, like it is in bracket, let's open it, 2 root 6 minus 2x1, and when it minus 2x1, if minus 2x1 goes here, then we will gain 2x1 plus x2. This plus goes here, then goes minus x3 is equals to 2 root 6. Does it correlate with this first equation that is set out, that sets out the definition of linear equation? Yes, a1 is equals to 2 and x1, a2 is equals to 1, x2 minus 1 means a3, and x3 is equals to b, which is also a real number, 2 root 6. So we can say this is also a linear equation. Now then you'll be asking, brother, what is not linear equation? Can you give example? Yeah, we'll be discussing this in these sets. 4x1 minus 5x2 is equals to x1 x2. Now if we look and ask ourselves a question about, does it correlate with this first definition of linear equation? Then the answer is no, because a1 x1, like 4 is a1 and x1, a2 is minus 5 and x2, and here must is equals to b is equals to x1 x2. Is there two variables? No, they are of degree first, but it is of degree second. So we're gonna, it is, it does not fulfill the definition of linear equation, so it is not linear equation. Is it linear equation? No. Why? Because if we make there is 1, a2 is equals to 1, x2 2, is there x1? No, there is x1 x1, and power is 1 by 2. So it is it, the question is it of degree 1? No, so it is not linear. If it was of degree 1, if the x1 degree was of 1, then it will correlate with this definition of linear equation, but eventually it does not made it. So it's not linear equation. So we have discussed two sets. One was of linear equation, one was not of linear equation. So we will move out on second. What is on second is A system of linear equation. Yeah, what is called system? What is system of linear equation? Or linear system. What is linear system? They are a collection of one or more linear equation. They are not only one but of two. Two equation, two linear must be linear equation involving the same variable. That means there will be two equations. This is first and this is second. They are of the same variable. Are they of same variable? X1, x1, x2, and there will be 0 x2, so there is also x2 and x3 x3. So it is called the system of linear equation, and everyone has a degree 1, and it does not violate the definition of linear equation. So we can call it the system of linear equation or the linear system. Now we have read two things: what is linear equation and what is system of linear equation, or what is linear system. Now let's move on. Third, now we have what is solution of the system. We have known what is system, what is linear system. If there is two or more equation of the same variable, then they are called the a linear system. If they are of linear equations, if they are not of linear equation, we can call it the linear system. So what is solution of the system then? A solution of the system is a list. It is a list s1 s2 up to sn of numbers that makes each equation a true statement when the values s1 s2 up to sn are substituted for x1 x2 up to sn respectively. If they are in the order, then it will be right. If they are not in the order, so we have said it like in the order, they must be in the order. Like here 6.53, they are in the order for x1, x2, and x3. So we will substitute them for x1, x2, and x3. Now this system, does it satisfy this equation and this equation? They are both systems that we have discussed on previous number 2 on the system. And if we substitute 5 on x1 and 6.5 on x2 and 3 on x3, we will get 5 into 2 minus 6.5 plus 1.5 into 3. Are we getting 8? Yeah, it satisfies. X1 minus 4 x3 minus 7 5, here is plus 0 x2, and so there is no x2, and minus 4 x3 is equals to minus 7. Is it satisfied? Yeah, so we can say they are the solution sets for these linear systems. So we have discussed what is solution of the system. The set of all possible solution is called solution set of the linear system. They are not only the like they are one solutions, but multiple solutions will be satisfied for these systems. So they are called solution sets. Two linear systems are called equivalent if they have same solution set. Now equivalent, it is equivalent if two linear systems are called equivalent, they have the same solution set. If the other equation, not these but another linear system that will be worked out on these solution sets, then we can call the these and the other, which we had hypothesized, linear system, then they will be on equivalent. Then they can be called equivalent if each solution of the first system is a solution of the second system, and each solution of the second system to the first system, then they are called equivalent. Now the question remained. The question will be remain would have remained in your mind that if one solution satisfies first, then it satisfies on second. Is it on vice versa? The answer is yes. If the second set has a solution that satisfied it, if two systems are equivalent, then the first system will be satisfied by the second, or vice versa. If you took first, then you make out solution, then the solution works on second if they are equivalent. So two process goes on. Now, what is exactly one solution? It is one linear system. X1 minus 2x2 is equals to, minus x1 plus 3x2 is equals to minus 3, and it is another. So it intersects at one point, so it have exactly one solution. If the two linear equations are the lines that are parallel to each other, then they have no solutions. If they overlap to each other, then they have infinitely many solutions. Now the solution set probability, now we have looked is we have discussed what are solution sets. If they have exactly one solution, the solution set have one solution. If there is no solution, then the solution set will be empty. If there are many solutions, like they will be overlapping, then the solution set is infinite. A system of linear equation has no solution or exactly one solution or infinitely many solutions. Now we have discussed the first, what we discussed on first sorry first on one we discussed linear equation. On second we discussed about linear system. On third we discussed about solution and solution solution set. On fourth, we discussed about possibilities, possibilities of solution sets. And now we will on to next. Now the next is on, can we convert linear system into matrix? Can we written them as matrix? Yes. Now we will be discussing about then first what is consistent, what is when a system of equation is said to be consistent. A system of equation is said to be consistent if it has either one solution or infinitely many solutions. If it has no solution, then the system is inconsistent. And now we will be discussing how to make matrix. The essential information of a linear system can be recorded compactly in a rectangular array called matrix. What is matrix? How a matrix can be recorded? What is matrix? There are only the rectangular array in which the linear system uh, these systems information is recorded in a rectangular array which we call matrix. Now when we see this system, then how is it recorded on matrix, this information? Then here is 1 minus 2, here is minus 2, here is 1 and here is 1, and here is 0 and here is 0, 2, 2, 8, 8 minus 8, sorry, 5, 5, 0, 0, x3 minus 5 minus 5. What are they? They are only these. We haven't included these. Only these matrix, these informations matrix is called coefficient matrix, or we call matrix of coefficient. And if we make augmented matrix 1, 0, 5 minus 2, 2, 0, 0, 1 minus 8 minus 5, 0, 8, 10, then they are called augmented matrix. Basically, why are they called augmented matrix is augmented means gluing, just they are glued. They are partials, but they are glued or they are mixed, so they are called augmented matrix. And if there is not this part or the exclusion of this part, and only this part we call matrix coefficient. If m and n are positive integers, and m into n matrix is a rectangular array of numbers with m rows and n columns. If a matrix is the information here goes on. If on the right side here writes m into n, then we must be consider there are m rows, this is first row, second row, and there are m row, and here is first column, second column, and there are n column, and we write this m into n. Now how we solve a linear system, this is the first problem. I hope you will try, and I will be pause and no not I will be pause and try, and we will be discussing this. Now the solution. Hope you solved. If you didn't solve, then we'll be solving this. First, we write them as augmented matrix. Then we'll be making these 1, 0, 5. There is 0 and 5. We'll make both of them 0, as this part is already 0. We'll make this part 0. So the last row must be divided by multiplying 5. Sorry, not divided, by multiplying 5 and then subtracting, which makes 5 minus 5, 0. and minus 2 multiplied by 5, minus 10, and minus 10, 10. When there will be minus subtraction 1, minus 8, and when it is multiplied by 5 and then subtracting, we will get minus 10 and 0 and 10. Now we got 0 0, and we need here 0, we need here 0, and we make them first 1 by dividing by 10, 1 minus 1 1. Then we subtract here the second row, we subtract the third row by second row, and we make 0 3 minus 3. Now here back substitution will work. Now we got x3, x3, 3x3 is equals to minus 3. We can say x3 is equals to minus 1, and we can do back solving by like x3, and then we put the value, or we multiply it by 4 and then add to it, then we get like 0, and we get x2 is equals to 0, and here we get x1 is equals to 1 by multiplying by 2 and adding to it, we get x1 is equals to 1. So we solve the equation and we can check these values. So if here is 1 1 1, then it is x1, this is x2, and this is x3. We call them pivots. We will be discussing in the later chapter. Now we got solution. We will be talking about what is elementary row operation on solving the matrix linear system. First, we replace one row by the sum of itself and a multiple of another row. We can basically say add to one row a multiple of another row. We can like multiply one row with minus 5 and then add to them and get 0 0. Interchange two rows. We can interchange two rows. We can interchange two rows, like row 1 can be changed with row 2 in the matrix or the system. Scaling, multiply all entries in a row by non-zero constant. We can multiply row 1 by 3, and we must multiply all of them in the augmented matrix, and it will be pretty much same. And they will be of same value. We can also divide them and they will be same. Row operation can be applied to any matrix. They are row operations. What we can do on row operation to solve them: two matrices are row equivalent if there is a sequence of elementary row operation that transform one matrix to the other. Two matrices are equivalent matrices, which means they have same solution sets on elementary row operation. That means if we do addition subtraction on one matrix of a linear system, or scaled or interchange or whatever we do, the solution remains same as the first equation. How many steps you will do, the solution sets will be pretty much same. Note, row operations are reversible. We can interchange row 1 with row 2, then we can also interchange row 2 with row 1, and that makes same. And we can solve row 1, we can scale row 1 by c, and then again scale row 1 by c, which makes them a reversible. And row operations are reversible, we have to keep in mind. Now on 6, if the augmented matrix of two linear systems are row equivalent, then the two systems have the same solution set. And if they are row equivalent, then the two systems have the same solution sets. The augmented if two augmented matrix means the matrix what we called was on the system we called equivalent sets or equivalent, and on the matrix we call row equivalent. So they are pretty much same as equivalent, but on a row equivalent they have also same solution set. Two matrix have same solution set. Justification: suppose a system is changed to a new one via row operations. By considering row operations, any solution of the original system remains a solution of a new system and converse. Suppose a system is changed, suppose a matrix is changed, suppose a matrix is changed by row operations, by when it is scaled or add and multiply with one another, by multiplying or by interchanging. But we can make converse of them, which makes them the pretty much same solution set. Same solution set. So here calls any solution of the original system remains a solution of a new system and converts on row operations. Existence and uniqueness question. On a linear algebra, this is the huge questions on existence and uniqueness. This will be on every chapters to determine which possibility, that is one solution, no solution, or infinitely many solutions, is true for a particular system. Asks two questions. The first question is the system consistent? If the system is consistent, then they have one solutions or infinitely many solutions. But if not, there will be no solutions. Then they are not inconsistent, which makes existence question. And on uniqueness question, if the solution exists, is it the only one? If there is one solution, then it is unique. If there is many, they are not unique. So to make the uniqueness question, it is for only one solution. If it is existence, they are for one solution, and infinitely many solutions, but not for no solution. So these two questions complete existence and uniqueness questions. Now on 7, how to determine if the solution following system is consistent. Now we took the system x1 minus 2x2 plus x3 is equals to 0, 2x2 minus 8x3 is equals to 8, 5x1 minus 5x3 is equals to 10. Then we write them in matrix notation. Then we solve them firstly by minus 5. And we have already discussed this equation, this solution, and we will be going. Here, if we look, x3 is equals to minus 1, we can substitute these in these, and we get the value of x1 x2, which is x2 is equals to 0. Or if we put any x2, we will get 0. This means x2 is infinite. No, let me look at it. No, there will not be. X1 is equals to x3 is equals to minus 1. X2 is equals to 1 minute. I will do them. X2 is equals to minus 4, which makes them plus 4 is equals to 4. Oh folks, x2 must be 0. No solution. No, not solution, but the solution is infinite. So the solution exists, but the solution is not unique, I would say that. Determine if the following system is consistent. Now like if we, when will we interchange, is if we find this first row and the first column, the first a1 are these first element to be 0, then we have to interchange so that we can make pivots. So if we make it 0, we can make it 0, but we can't make them 0, so we must interchange by one of them, and our calculation will be easy. And we will solve them, and here we get 0 0 0 15. 0 is equals to 15. Can 0 be is equals to 15? No, we can't get them. So the solution has no solution. The system has no solution. If the system has no solution, then the system is inconsistent, we can say. Now I made a mistake here. The solution is not unique. Sorry for